Okay, so we were just finishing up number 13. We were solving for mass of the canoe final. We took the mass of the terms with the person A and person B to the other side. They both became negative. And to get the velocity of the canoe final, we need to divide by the mass of the canoe. And so we get m of the canoe, or v of the canoe final equals m of person A, 80 kilograms. Velocity of person A going off the front side, so I'm going to call the front positive. So 3 meters per second minus mass of person B is 70 kilograms. And they're going off the back, so I need to put their 4 meters per second in as a negative. And then divided by the mass of the canoe, 50 kilograms. So on the top, that's going to be negative 240 kilogram meters per second. Minus a minus, so plus 280 kilogram meters per second divided by 50 kilograms. So on the top, positive 40. On the bottom, 50. So 4 over 5, 0.8, and it works out to be positive. So V of the canoe final is 0.8 meters per second, and it's going to be forward the way person A is going. Okay? Number 14. A 15 kilogram body is moving north 2 meters per second. Okay. So 15 kilograms. And its initially, V1 initial, is 2 meters per second north. When it collides and becomes coupled to a second body of mass 25 kilograms moving south. So 25 kilograms. And it's going south. So V2 initial, 4 meters per second. And that's south. So after the collision, they stick together. And the first part is what's their velocity, and the second part is it elastic. So first, M1 V1 initial plus M2 V2 initial equals M1 V1 final, M2 V2 final. And again, they join together, so their V finals are going to be the same, so factor that out. So it's M1 M plus M2 V final. This side doesn't change. And now you're going to solve for V final by dividing by the M1 plus M2 on each side. Okay, so this cancels. So you have VF. M1 is 15 kilograms. Initial is 2 meters per second, and it's north, so we call that positive. Plus M2 is 25 kilograms, and it's going south, so negative 4 meters per second. And then you're going to divide by 15 kilograms plus 25 kilograms. So 30 minus 100 is negative 70, and on the bottom, over 40. So 7 over 4, so it should be 1.75, and it's going to be negative, right? So the top is negative 70 kilogram meters per second, and the bottom is positive 40 kilograms. And so you end up with negative 1.75 meters per second, and this negative simply means south. So that's part A. Part B wants to know, is it elastic? So then that's when you go to 1/2 M1 V1 initial squared plus 1/2 M2 V2 initial squared equals 1/2. And they join together after, so make your life easy and write this as M1 plus M2 V final squared. Okay, so 1/2, the first mass was 15 kilograms. Times 2 meters per second, and that gets squared, plus 1/2, 25 kilograms, times negative 4 meters per second, and that negative really isn't going to matter because it's going to get squared, equals 1/2. 25 plus 15 is 40 kilograms. And we just found our speed to be negative 1.75 meters per second squared. And again, when you square that, the negative's going to disappear. So 4/2 of which is 2 times 15. So the first term is 30 joules. Plus 16/2 is 825, 200 joules. So this side, did I do that right? Yeah. And the other side, 1.75 squared, half 20, 61.25, I think. Joules. I might just check that because I'm not sure I got 1.75 squared in my head correctly. Times 20. Yeah. And so the first side is 230 joules. The second side is 61.25 joules. I don't think they're equal. So you draw a line through it and you write the word inelastic. Okay? And when they're not equal, the final should always be less than the initial. The initial, it needs to be bigger or equal to. There's no way you could end up with more energy than what you started with. Okay, so if that ever happens, either I screwed up making the question or you screwed up creating the answer. In this case, we didn't screw up. The final's smaller than the initial. This is inelastic. All is good. All right, time to practice some more.